So we've been talking a lot about conversion factors and using them in our calculations and getting used to doing these conversion pathways and streamlined calculations where units cancel. Now, in Chapter 2, we consider Avogadro's number and the molar mass as conversion factors in our calculations. So if you think about it, Avogadro's number really does look like a conversion factor because it is written as a rate. It's written as 6.022 times 10 to the 23rd, for example, atoms in a mole of atoms, so per mole. The number really has units of just per mole. So in the same way that a dozen has 12 units in it, a mole has this huge number, 6.022 times 10 to the 23rd, number of items in it. So if I have a mole of tungsten atoms, then I have Avogadro's number of tungsten atoms. If I have a mole of molecules, I have Avogadro's number of molecules. If I have a dozen atoms, I have 12 atoms. So molar mass is also a conversion factor. It tells you how many grams of a substance there is in a mole. Okay, so in this particular question, let's reveal it. The question asks, how many atoms of tungsten, and the element symbol for tungsten is W, are present in a piece of a tungsten filament, so a tiny wire that's only 2.00 centimeters long with a diameter of 1.33 millimeters. So if this question were given in an assignment, probably wouldn't give you the density because you have access to information and you could look it up. And you would find that at room temperature, the solid is 19.3 grams per cc or cubic centimeter. If this were given in a test, it would either be written like this in the question, or it would be somewhere on your data sheet with the information provided. Okay, so one thing that we do need to remember here is the volume of a cylinder. So I'm going to consider that this tiny filament wire has the shape of a little cylinder. So that formula wouldn't be given to you. You have to remember that one. So how are we going to figure this question out? Excuse me. So let's look right here. I started doing this and I didn't have the camera on, so I didn't want to repeat everything. So this is why I'm just uncovering it as we go. So there's our formula. There's my little filament sketched out here as a little wee cylinder. Pi r squared height, probably because you're used to seeing the cylinder drawn on its side, or just simply length if I consider it length of wire. The diameter is given as 1.33 millimeters. So of course its radius, which is what I would need, would be half that. The length is 2.00 centimeters. Pi, of course, is on your calculator. So if I could calculate the, and I can, calculate the volume of this tungsten wire, I would calculate it in cubic centimeters. As far as a conversion pathway goes, how are we going to solve ultimately this question? I would take the volume of that filament of tungsten and convert it using density, right, wouldn't we, to a mass in grams of tungsten. Once I have the mass in grams, here's where Chapter 2 is considering more conversion factors. Once I have the mass in grams, I would convert it to the number of moles of tungsten, and I would use the molecular weight that I find from the periodic table. Once I have the number of moles of tungsten, I convert that using Avogadro's number as a conversion factor to the number of atoms of tungsten. So I think where we need to start here is in excuse me, the calculation of the volume of the tungsten. And so I'm just going to move this up. Using my formula, pi r squared times the length, pi open bracket, my radius r is half the diameter that's given. The diameter was given as 1.33 millimeters. Half that to get my radius. I need to convert millimeters to centimeters, so I'm using a little metric conversion here. I know there are 10 millimeters in 1 centimeter. So inside the brackets I can get rid of my millimeter units and have centimeters. So once I have that number, I'll square it. My unit will be centimeters squared. I'll multiply that by 2.00 centimeters. So ultimately I'm going to have a volume in cubic centimeters. That volume numerically is 2.78 times 10 to the minus 2. Okay. Straightforward, but there is room here, of course, just for little errors, trivial errors, like forgetting to multiply by pi, because it doesn't have a unit, so I might not pick that up, or forgetting to divide by 2, or even forgetting to square, but writing this anyways. So just be careful there. So if I look back at my conversion pathway, I'm now supposed to take my volume, 2.78, times 10 to the minus 2 cubic centimeters, and it's a volume of tungsten. And I want to convert it to mass. So I'll use the density as a conversion factor. I want to get rid of cubic centimeters of tungsten and introduce my unit of mass in grams. My density tells me that I have 19.3 grams of tungsten in 1 cubic centimeter of tungsten. So that brings me to mass. In my next step, I'll use the molar mass. We say molecular weight often, we mean molar mass, and of tungsten. And so if I look at the periodic table and I find tungsten on here, and that's atomic number 74, I don't think, let me see, there you go, doesn't focus very well, but the molar mass of tungsten is 183.85 grams per mole. So I want to convert out of the unit grams and into the unit moles. Okay, so 1 mole of tungsten is, as I said, 183.85 grams of tungsten. Yeah. And then, oh, and maybe in another question that you do that's related to this, you would just be asked for the number of moles of tungsten contained in such a filament of that size. In that case, you would just stop here because your units would have brought you to moles. But we are asked for the number of atoms. So I'm going to take it one step further. I'm using Avogadro's number as a conversion factor now to convert moles of tungsten. So I want to get rid of this into a number of atoms of tungsten. Okay, so in a mole of anything, I know that I have, and this is not going to fit on here, 6.022 times 10 to the 23 in a mole. So let me hold that down here. Okay, so that didn't fit very well. I wrote my unit first. Okay, so let's plug this into the calculator again, confirming that my cubic centimeters of tungsten go out with cubic centimeters of tungsten. My grams of tungsten cancel with grams of tungsten. My moles of tungsten cancel with moles of tungsten, and I'm left with a number of atoms. And I get 1.76 times 10 to the 21. It's a super large number, as you would expect for counting atoms. And that's of tungsten. I'll just write the symbol W. Just verify that that is indeed 10 to the 21 because I'm counting decimal places on my calculator. And we'll just put a box around our final answer. Okay, so it's really like the chapter 1 stuff. We're just introducing 2 more things that we can use as a conversion factor, and both of them we're very familiar with, Avogadro's number and molar mass.